Rocket League cars feel stupidly fast, like miniature rocket fast. So naturally, I wanted to know something a little more specific. How fast do they actually gain speed, and at what point does holding boost stop doing all that much? So I did what any completely sane person would do, and I split a full boost run across the field into equal strips, recorded the times, and used calculus to figure out what the car was actually doing. Each strip was 2,048 Unreal units long, and I recorded the exact time the car crossed each boundary. My measured boundary times were T of 0 equals 0 seconds, T of 1 equals 1.68333 seconds, T of 2 equals 2.58333 seconds, T of 3 equals 3.46660 seconds, T of 4 equals 4.36660 seconds, and the last time T of 5 equals 5.23330 seconds. That gave me position over time data, and once you have that, you can start pulling speed out of it. So instead of just saying, yeah, the car gets fast, I could actually track how the motion changed across the field at certain intervals. At the end of the day, the question is pretty simple. How does the car's speed change over time? Because if the speed gain starts falling off hard near the cap, then a full boost run might be doing way less work at the end than people think. And if that is true, then cars gain more value from boosting towards the beginning, or in other words, as T approaches 0, the value of boost increases. So, for one of the middle points, I used the positions on either side of it. That gave me V of T sub 2 equals 6,144 minus 2,048 Unreal units over 3.46660 minus 1.68333 seconds. This ends up equaling 2,296.31 Unreal units per second. Then I repeated that for the other interior points, and the estimated velocities came out to V of T sub 1 equaled 1,585.55 Unreal units per second, V of T sub 2 and V of T sub 3 equaled 2,296.31 Unreal units per second, and V of T sub 4 equaled 2,318.45 Unreal units per second. So the graph absolutely shoots up, and then it starts flattening out near the speed cap. And then I pushed it one step further. Once I had velocity, I could use the same idea again to estimate acceleration. So now I'm not just asking how fast the car is going, I'm asking how fast that speed is actually changing. The formula is A of T sub I equals V of T sub I plus 1 minus V of T sub I minus 1 over T sub I plus 1 minus T sub I minus 1. Using that, I got A of T sub 2 equals 2,296.31 minus 1,585.55 Unreal units divided by 3.4660 minus 1.68333 seconds, which ends up equaling 398.57 Unreal units per second squared. And then A of T sub 3 equals 2,318.45 minus 2,296.31 Unreal units over 4.36660 minus 2.5833 seconds, which ends up equaling 12.42 Unreal units per second squared. So the math is telling us something pretty important. Rocket League cars do not spend much time accelerating that hard. Most of the real speed gain happens early on. After that, the car is basically just creeping into the speed gap, and the rate of acceleration starts to approach 0. In other words, the early part of boost is doing the heavy lifting, and once you're already moving near top speed, continuing to use boost gives you way less extra speed than you probably feel like it does. So if you've ever had that weird feeling that full boosting forever isn't really making it that much faster, you're not crazy. The numbers actually back you up. There's one piece of information I found during my research that makes everything way more interesting. I found an 11-year-old Reddit post from Psyonix Dave, one of the Rocket League developers, where he explains the scale that they use for Rocket League's speed display. And for that, they use the small car scale of 1 Unreal unit equals 1 centimeter. He also provides the official top speed of the car, which comes out to 2,300 Unreal units per second, which works out to be about 82.8 kilometers per hour or 51.4 miles per hour. Now, if you notice that a couple of my velocity estimates landed just a little bit above 2,300, that does not mean the car is actually breaking the cap. Then, Psyonix Dave actually says something even better. If you scale up the car using the factor of 3.653, the same top speed comes out to about 190 miles per hour. So in Rocket League's literal display scale, the car is topping out at about 51.4 miles per hour. So in dev-backed real car feel scale, it's more like 190 miles per hour. And honestly, that second number feels a lot more like Rocket League. If you enjoyed this one, like and subscribe to help fund my astrophysics degree and to keep the calculus coming. So yeah, Rocket League movement feels pretty simple when you're in the match, but under the hood, it's kind of a tiny physics experiment. Most of the real speed gain happens early, and once you're near the cap, boost starts to give you diminishing returns, which is honestly way cooler than I expected. Next, I kind of want to test diagonal flips, wave dashes, or the fastest way possible to hit supersonic. Further transmissions are available on this channel,